Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and a little bit of computer science. And in this video, we're going to evaluate a definite integral using the definition. So we're not going to use those formulas. If you're familiar with those formulas, this would just be 1/3 x cubed evaluated from 0 to 3. We're not going to do that in this video. We're going to use the limit definition. So what is the limit definition? Well, it can actually be written in many different forms. But the way I want to use it here is the integral from a to b of f of x dx equals the limit as n goes to positive infinity of the sum from I equals 0 to n of f of a plus I delta x times delta x. All right, so notice here we have the integral from a to b of f of x dx, but over here there's no b. Well, actually there is a b. It's sort of hidden inside the delta x, because what's delta x? Well, delta x is b minus a over n. Okay? So that's what's going on there. So let's go ahead and figure out what's happening in our specific case. So in our specific case, we have the integral from 0 to 3 of x squared dx equals the limit as n goes to positive infinity. That should say positive infinity. Of the sum from I equals 0 to n of what? F of, well, what's happening? So what's a and b in our case? Well, in our case, a is 0, b is 3. So what's delta x? Well, in our case, delta x is b minus a, which is 3 minus 0, over n. N is just n. So that's 3 over n. So this, and don't forget about the I over here, where the I is the index variable on the sum. So I delta x is I times 3 over n, which is 3i over n. Okay, so a plus I delta x equals 0 plus I times 3 over n, which is just 3i over n. So that's where this 3i over n came from here. And then times delta x. Remember, delta x is just 3 over n. So that's what's happening there. Now, what I want to do is forget about the limit for now, and then let's just focus on this. Just focus on that part by itself. Okay? So what we want to do then is look at that sum separately. So let's go look at the sum from I equals 0 to n of f of 3i over n times 3 over n. Now, what is f of 3i over n? Well, here's our f of x. Okay, our f of x is just x squared. So f of x is x squared. So what that means then is that f of 3i over n is 3i over n, that whole thing squared, which is 9i squared over n squared. Okay? So the sum is equal to the sum from I equals 0 to n of 9i squared over n squared times 3 over n. Now, all the numbers and the n's we can just pull out of the sum, okay? But the i's have to stay inside the sum because the I is the index variable. So the sum depends on what the current value of I is. And technically the sum also depends on n, but it's okay because the sum stops at n. So n is just a constant as far as the sum is concerned, but I is not a constant. N is, which is why we can pull n out. So when we pull out the 9 times 3 on top and the n squared times n on bottom, we get 27 over n cubed times the sum from I equals 0 to n of I squared. Okay, now this is a sum that has a known formula, and that formula is, well, first we have 27 over n cubed still, and then times, this is n times n plus 1 times 2n plus 1, all divided by 6. Now let's go ahead and simplify this a little further. So one of these n's cancels with one of them down here, so this 3 now becomes a 2. 6 and 27 have a common factor of 3. Let's pull it out. That gives us 2 down here, and up here that gives us 9. Okay. Now what we have is 9 times n plus 1 times 2n plus 1, all divided by 2n squared. Now let's go ahead and expand on the top. We don't really have to necessarily, but it is going to make this a little bit easier later on. So when we expand on the top, we're going to get 9 times, actually let me move over to the left a little more. We're going to get 9 times, so here we're just going to FOIL. So we get 2n squared plus 2n plus 3n, so that, or sorry, 2n plus 1n gives us 3n, and then plus 1 all over 2n squared. Now let's distribute the 9, and then we'll be done with this part. So this is going to be 18n squared plus 27n plus 9, all divided by 2n squared. Okay, so this right here, I'm going to circle with a red poofy cloud. This right here is equal to this sum here without the limit, okay, without the limit. So what we just found out then is that this equals the limit as n goes to positive infinity of 18n squared plus 27n plus 27n plus 9, that's an n right there, all divided by 2n squared, right? Yes. Okay, now this is just pretty much the type of limit like you would have seen near the beginning of Calc 1, most likely. So what we want to do is look at the highest power of n on top, it's 2. Look at the highest power of n on bottom, it's also 2. That's great. The highest power of n on the top and the bottom is the same. So now what we want to do is focus on the leading coefficients. 18 on top, 2 on bottom. So that says that this limit then, let's maybe keep the color the same. This limit then is going to be equal to the leading coefficient on top divided by the leading coefficient on the bottom. Leading coefficient on top is 18, on the bottom it's 2. 18 divided by 2 is 9, and that is our final answer. So using the definition of definite integrals, we've just seen that the integral from 0 to 3 of x squared dx equals 9. Okay, so this has been an example of using the limit definition of a definite integral to evaluate a definite integral. And again, this limit definition can be written in many, many, many different ways. This is just the way that I wanted to use it for this particular problem. Anyway, I hope you found this video helpful, and thank you for watching.